Hey everyone, welcome back to the Maverick channel. And if you're new to this channel, we talk about cryptocurrencies, we talk about the trends in the digital currency space, everything to do with cryptocurrencies. So let it be regulation in government, let it be latest trends or real world use cases in cryptocurrencies. How can some of these blockchains and cryptos be used in a real world scenario? Now, one thing I wanted to talk about is that most people are here because of value. How much value they can extract from these blockchains, how much value can they obtain from these ecosystems. And I want to talk about something called MEV, or Maximal Extractable Value, formerly known as Minor Extractable Value. Essentially, just think of this as third parties. You have blockchain systems that are immutable, that are secure, that have a pseudonymous nature to them. In other words, a pseudo privacy nature to them. The users are private, but you can see whatever happens on these blockchain systems. So MEV is a way to be a mediary, a counterparty kind of mediary player in there. You're an intermediate player that looks for ways of extracting these overlaying values or these overlying values. Maybe a user is performing a transaction, but they don't mind paying a little extra fee on that transaction. So you could be an intermediator that makes sure something goes down. By the time this transaction happens, you've actually extracted some of this value. So just think of it as a mediator and as an intermediary. I can give you an example. This concept can also apply to NFTs. You all know NFTs, you know the NFT craze. The interface of NFTs is quite easy. You have a picture, you have an artist that draws something, and you know what it is, and you know that it's on maybe the interplanetary file system. That's where its data is backed up, but you see the picture on the user interface. Now, where does MEV, or maximal extractable value, this fancy word, how does it apply to NFTs? Well, essentially, a user might have a bunch of NFTs, or you might have a floor price on NFTs. So first, keep a pin on that. So if a user has a bunch of NFTs and they list these high level NFTs at a low price by mistake, you can have a bot that goes in there and immediately captures the flow of this NFT or immediately buys it. And there you're essentially leveraging, or you're taking advantage of what we call an MEV, because essentially these signatures or these transactions are happening on the blockchain. Then you might look at some novel NFTs. For example, in the past, we have some NFTs like the CryptoPunks. So what happens, there was a time there was a very low flow in these CryptoPunks, and a certain private user was able to extract all the CryptoPunks, all the floor prices, were able to essentially sweep all these CryptoPunks with a value of $7 million. So, I mean, we know crypto. Different kinds of people, you don't know who they are. They have all kinds of money out there. They have thousands of Ethereum, thousands of Bitcoin, thousands of BNB, Polygon, whatever other cryptocurrencies you might want. Some people have a ton of money. So this person essentially swept $7 million worth of floor prices of CryptoPunks because they wanted to leverage. They realized, the market is in a panic. Let me just send a bot that's literally going to sweep all the CryptoPunks, because if you do it individually, it's going to take a lot of time. The market is going to notice what you're doing, and that's going to send ripple effects that are going to increase the prices of the punks or whatever NFTs you're looking for. So essentially, MEV is a way of being an intermediary to capture value. So this concept largely started with Ethereum. So with Ethereum, by the time Ethereum was a proof of work chain, this was known as minor extractable value because it was applicable to miners. Then Ethereum transitioned to proof of stake, and this became to be known as maximal extractable value because it just didn't apply to just miners, but it applied to validators. So validators, for those that might not know, in a proof of stake network, in proof of work you have miners, in proof of stake you have validators. These are people that might propose blocks, or when a network is sticking, they help to ensure the security of a network by essentially making sure that each block that pops up, they actually validate that the transactions in this block are true. So the validators help to do that through a staking mechanism. They stake cryptocurrencies, or users or people of interest in that, all kinds of stakeholders that own tokens of that particular blockchain will stake their tokens with different validators. Now, it's of course imperative, it's important that a network has a lot of validators where token distribution is, evenly distributed, or at least very well distributed, so you don't have a problem of centralization. So these validators ideally are supposed to take advantage of MEV. In other words, you have fees, high fees on the network. They're supposed to go to the validators. At least that's the theoretical bit of it. But that's not the actual case, or it may not necessarily be the case, because you might have individual parties that may not necessarily be validators that launch these things we call bots. These bots, their purpose is to go look out for value. So this may apply on maybe a decentralized exchange where you have someone that sets up bots to go and look for different prices on different large decentralized exchanges. So we're talking about a situation of arbitrage. Arbitrage is where you buy cryptocurrencies from one exchange and then you sell it on another exchange. So you might buy something that's worth 50 cents on this exchange, but you realize on another exchange it's actually selling for 60 cents. So you buy up a bunch of it and you sell it on another exchange and you make a bunch of money. That is an example of maximal extractable value. Another example is you might send out a bot that's looking out for users that are, initiating very large trades. So these trades are going to, for example, someone saying, I'm going to buy Uniswap. I'm going to buy $10,000 worth of Uni tokens. And this is all happening on the centralized exchange. And you know that this is obviously going to knock up the price of Uniswap because we're in a bear market. So what that bot does, or what these people are called searchers, by the way, I don't know if I mentioned that. These people that create those bots that look out for that value are called searchers. So now this searcher creates a bot that goes out and looks for those kinds of trades. So before that trade of $10,000 to buy a certain amount of Uni tokens, before it's executed, that bot actually makes sure it purchases some Uni tokens right before that transaction is executed. So they buy a bunch of Uni tokens and that other heavy transaction is executed, which then causes the price to hike up, which then this bot then realizes the price has hiked up or the transaction has been executed, and then sells that previously bought transaction after the large transaction has been executed. So this user has essentially been able to extract value by looking at the market conditions and extracting them and taking advantage of them. Another example is in liquidity pools or liquidation or collateralized position. A user, this is in a sense of borrowing and lending in decentralized exchanges. So you might have a loser a loser. In this case, there might be a loser actually. So a user has $100, let's say in DAI. DAI is is essentially the biggest decentralized stablecoin on the Ethereum network. So they might put $100, place $100 of DAI, worth of DAI as collateral. And on the other side, they borrow maybe $30 worth of DAI in multiple other assets, because some of these platforms, what they do is that they offer multiple collateralization in multiple assets. So you might place $100 worth of DAI on an exchange, and then you borrow $30 worth of collateral in different assets. So it might so happen that due to the fluctuation nature of cryptocurrencies, some of your assets actually go up in value. Your borrowed amount actually goes up in value. So when this borrowed amount goes up in value, what happens is that you may incur what we call an under collateralized position. So now your borrowed amount is probably like 50-30% above your collateralized assets. So this is where a user or a searcher brings in a bot to liquidate your assets, because you need to be liquidated. Of course, some advantages that come with this are the decentralized exchange does not become insolvent. It continues to be solvent because there's this constant transactions, buying and selling. So your collateralized position, your under collateralized position is then liquidated, and that liquid position is bought by that so-called searcher or the bot of that searcher. And because you have to rush in and pay your position, because you charged very high fees if you actually liquidate it. So a user has to go back and pay high fees so that they're not to watch their position. And in doing so, the person that actually purchased that under collateralized position gets rewarded in fees. Some of those fees go to them. So that's another way that some of these searchers that leverage maximal extractable value can actually attain or obtain money in doing so. There's many other examples I can give you. For example, there is a user at one time that purchased about $1.3 million worth of uni tokens on one exchange, and then went to another exchange and was able to buy. I mean, they spent 1,000 Ethereum buying tokens, and then they went to another exchange and ended up buying in excess. They converted the Ethereum to USD, to a stablecoin, went to another exchange, decentralized exchange, and were able to convert those stablecoins back to 1,045 Ethereum. So that's another way of looking at this MEV situation. The reason why I'm talking about this video now, there's different solutions to solve this, but there's good size to MEV, there's bad size to MEV. For example, we have front running in MEV. This is the thing we talked about. A user places a large order, but then you want to place a transaction before them. So because you place a transaction before them, you're gonna give them a bad deal. You've bought before them, which means you're going to increase the price of the tokens, which means they're going to buy at a price higher than they had wanted, and at the end you're going to sell. So the person with the large transaction is going to lose out. So that's one of the disadvantages. There's other types of MEV, like sandwiching MEV, because we talked about liquidation. That's the type of MEV. We've talked about front running, the one I've just explained. There's something called sandwiching, which is, I think, the same thing, where you place a transaction before and a transaction after. That is sandwiching. So there's different ways of looking at it. But as I said, it's sort of being a third-party intermediary that's looking to extract different value, or different ways of extracting value in these ecosystems. So there's different solutions in the Ethereum network. There's scaling solutions like the rollups. So they want to, some of the rollup scaling solutions want to implement certain MEV solutions, but the issue is obviously, we know the disadvantages. If you have some of these solutions, if you have excessive MEV, some of the validators, because they want to extract as much value as possible, it might lead to centralization, because each validator wants to capture that block that has the most fees. Because another disadvantage is that when different users want to extract as much value as possible, they send through transactions. So because they send through transactions, they can copy some of the blocks that actually are seen to be hotpots. Now, that's another type of MEV. So another person, actually, that is front running. So a person can copy a block that seems to be like a hotpot, that's going to have the best extractable value, and export it to their own transaction or their own block. And in doing so, they're able to extract all that value. Now, all these different types of competition that happen as different users are trying to extract as much value as possible lead to a spike in the fees in the blockchain, to which, in the native blockchain, the parent blockchain, to which this is happening. So this spike in fees, of course, leads to network congestion. It leads to users losing out because they want to use the block. They don't know what the heck's going on, and they're seeing all these fees spiking up. So that creates a congestion in the network. Another disadvantage is that some of these validators, because this is happening, they will actually create multiple validator nodes, because some networks have a maximum number of validator nodes, but some users might actually create multiple validator nodes so that they increase their chances of capturing value from different blockchains, or different scenarios where they might actually capture value. So that's another disadvantage of MEV. Now, if you try to control this so much, you might create a centralization, because there's some solutions trying to look for, like the rollup solution or MEV auctioning. Different networks, like even the Cosmos network, they want to look at solutions where this MEV applies to a particular application chain. For example, in Cosmos, as opposed to Ethereum, which is more linear, in Cosmos you have specific blockchains. You're leveraging the technology. It can communicate with one another through things like the IBC, the Inter-Blockchain Communication Protocol, but you can actually design certain specifications based on the blockchain that your own blockchain, based on your needs, based on your wants, based on your use case, and you can design your MEV solutions based off that. So some blockchains like Cosmos want to look at things in that way, where you can customize that MEV. Whereas in Ethereum, they're looking at more off-chain solutions, where you look at maybe second layer solutions trying to fix some of these MEV issues. So obviously we looked at rollups, so you can look at some solutions like the Shadow Network or Optimism, whereas in Cosmos you can look at maybe Osmosis, the Say Network. These are, I'll post some of the links in the description of some where you can see some reliable research about this. And if you want to look more into this, if you want to extract more value from this whole idea of maximal extractable value, you can get into the midst of the articles and see how to actually tackle it or how to go about it. Maybe you might have an interest. So essentially, these are different ways in which you can extract value, and some companies or some people are actually designing ways to have a quick press button where each validator on a network can actually choose to extract value. So depending on maybe who engages it first, or depending on what is going on in the network, you might actually be able to leverage that benign MEV extraction to leverage value in a way that does not negatively affect the network. So I wanted to cover this topic because it's quite an interesting topic to me, but at the same time, when you try to look out for information about it, it seems to be quite complicated. But in short, it's just a way to act as an intermediary in different blockchain transactions, sign transaction in different ways, so that you extract value in different ways. That's pretty much it. That's maximum extractable value. So guys, I hope you enjoyed this video. I hope you got some value from this video. We have a lot to cover because I haven't done a video in a long time. So make sure you stay tuned to the Maverick channel for more content like this. See you soon, guys. Take care. Bye-bye.